2 of our practice tests for section 6.4 to 6.8. And the second part of this generally goes a little faster than the first. Solving, like we did yesterday, it takes a while. So find the composite function. F of x equals negative 2x plus 6. G of x equals x squared plus 7. And it's g of f of x. Now remember, we can always write that in parentheses so that it helps us figure out exactly what's going on. So g of f of x. Now, this is where we have to put one function inside another function. And the parentheses tell us that. They're saying take f of x and put it into g of x. So we have to take this and put it in the input, which would be the x. So we'll have negative 2x plus 6 squared plus 7. Now remind me again, how do we square negative 2x plus 6? We got to write it out twice, don't we, in FOIL? Yeah, we had to do that yesterday, too. And we have to keep track of the nasty negatives in this one. So negative 2x times negative 2x is going to give you a positive 4x squared. Outside times outside, minus 12x. Inside times inside, minus 12x. Last times last, plus 36. And then we have that plus 7 in the back. What do you suppose we should do next? Absolutely combine like terms. Yes, we absolutely will combine like terms. So 4x squared minus 24x plus 43. That's the composite function. So just remember, the one that's closest to the variable, that's the one we have to put in first, then go backwards and go to the second one. So for this one over here, we want f of g of x. So please help me out more with this one. Which one goes into which one? Which one do we substitute into the other? G of x this time. So g of x goes into f of x. This goes here. Now this is another one where it's really important that you have those parentheses in there. Where is somebody going to make a mistake on this one? Yeah, the negatives, by not distributing the negative. So we're not going to do that. Everybody in here tomorrow is going to make this, do this problem correctly, because they're going to remember, hey, I have to distribute that negative. So that one's a little bit faster because we didn't have to do any squaring as we went through it. So far, so good? All right, so next one we have says f of x is 2x minus 7 and g of x is x squared plus 2. Find the value of the composition. Again, you wouldn't have to change it to parentheses. You just have to remember negative 3 goes into the one that's closest to it first and then goes into the f. But if you wanted to, you could write it like this. And again, just think of it as innermost parentheses first. That's what we always do in math. So we need to put negative 3 into g and see what we get. Well, here's g right here. So it's going to be negative 3 squared plus 2. And make sure you use parentheses if you're going to use a calculator for this one. But I probably wouldn't even use a calculator, because what's negative 3 times negative 3, everybody? 9. So this is just going to be 9 plus 2, which is 11. Now, if we stop there, we're going to get it wrong. Why? We didn't put it in the other one yet. Yeah. It says put it into G and then back up and put it into F. So now we have to put it, there's our second step, step 2, put 11, 2 times 11 minus 7 into f of x and see what we get. So what is 2 times 11? 22. And what is 22 minus 7? 15. And we've got it. So closest variable first, that's where it goes. Get your answer and plug it into the other variable. All right, now we're down to inverses. Now we're getting close. This was section 6-7. Find the inverse of each function, and then we're supposed to answer, is the inverse of function yes or no, and explain. But let's just worry about finding the inverse first. Step 1 to finding any inverse. Come on, you know this. Step 1. Change the y and the x. Right now it doesn't have a y, but we know that f of x is the same thing as y. So you switch the x and the y, and then what do? We got to get y by itself, exactly. Now we can't get to y right now because it has a square root attached to it. So how do you undo square root? Let's square both sides. Almost have y by itself. What do we have to do to finish it up? Subtract 16 from both sides. And I'm going to give it the fancy name. I am not going to take off points tomorrow if you write y equals. So you could just write y equals x squared minus 16. I'm going to take it either way. Alrighty. So the question is this a function or not? What do you think? If you put one number in, do you get one number back? So this is a function. In fact, it's a parabola if we were to graph it. So how do we explain that? Well, the easiest thing to do is to say, hey, it meets the definition of a function. So for every input, comma, there is exactly one output. Because that was something we should have memorized in first semester, so we don't have to memorize anything new. For every input, there's exactly one output. Just waiting here as I see some people are still writing. All right, let's go to 17. What's step 1 again? What's step 1 for finding an inverse? So it's the x and the y. So let's make this a y. And let's swap them out. Now we have to solve for y. How do we get y alone? All right, let's add 7. How do you undo y squared? Oh, square root. That means we have to put a plus or minus in front of it. And again, I'm going to write it with the fancy notation, but I will take it with y. If you write y equals plus or minus square root of x plus 7, it'd be totally fine. Is that a function? Big no. And then again, it's, well, how do you explain it? Well, just use the definition, but say for every input, there is not exactly one output. That way, again, you're not memorizing two different explanations. And every once in a while, somebody writes down on this one, for every input, there's 2 outputs. That's not true, because if we put negative 7 in here, we get 0, and that's just one output. So you can't say for every output, there's 2. Every input, there's 2 outputs. Just better to say for every input, there is not exactly one output, and then you're safe. You've got it explained. All right, doing okay with the inverses? So now, this stuff is fresh in our mind, and you were really good at it, so this isn't going to take us long at all. Analyze the transformation, graph the parent function and the transformed function, find the domain and range of the transformed function. So 18 has y equals negative square root of x minus 2 minus 3. So what we're going to use for our table again is y equals a square roots of x, or y equals a cubed roots of x, depending on whether or not it's a square root or a cube root. So in this one we have to take the negative along for our table. Do you remember the nice numbers we picked the other day when we were working with square roots? Anybody have the list? 0, 1, 4, 9. See, Jerome, there's another blank. Yeah, because we need the other blank for that one. We don't need it for this one. If you wanted to put 16 in there, you could do that, the next perfect square, if you want to fill it up. But for our graph from negative 10 to 10, 9 is going to be just fine. So we're going to take the square root, and then we're going to slap a negative in front of it. But the square root of 0 is 0, and whether or not you have a negative or not, that's going to be 0. Square root of 1 is 1. Put a negative in front of it. Square root of 4 is 2. Negative in front of that. Square root of 9 is 3. Negative in front of that. And like I said, if you want to do the 16, negative 4. Now that's our parent function. So we need to put this one on dashed or dotted. And that's because this one definitely has some translations taking place. So help me out, everybody. If this has square root of x minus 2 minus 3, where do we have to move that graph? Bless you. Right 2, down 3. And there's a spot down here to write that. Right 2 and down 3. And then we just go back up and take our 4 little points that we had there and move each one of them, right 2 and down 3. And then I see they want the domain and range, so I think for a second, where is that new starting point if I went right 2 and down 3? What are the coordinates for that starting point? 2, negative 3. So we know it's going to be x, something with 2, y, something with negative 3, and we can just look at the graph and figure out, should we put greater than or equal to, should we put less than or equal to, what do we need? So for the x's, what should we put between those two? Greater than or equal to, it's going right forever. How about our y's? Well, is the graph going up? Nope, so it's not greater than or equal to. Less than or equal to because our graph is going down. So those were our square root graphs. Then we had cube root graphs. So does anybody remember the nice numbers well, I should talk about the parent function first. This one doesn't have anything new in front of it, so it's just going to be y equals cubed root of x. I mean, we don't have a new a value for this one. So our nice numbers that we worked with the other day are going to be perfect for this one. Do you remember all the numbers we used for cube root? Negative 8, negative 1, 0, 1, and 8. Yes, the perfect cubes. Perfect cubes. So cubed root of negative 8, negative 2. Cubed root of negative 1, negative 1. Cubed root of 0 is 0. Cubed root of 1 is 1. And cubed root of 8 is 2. There's our parent. Let's get that on there. dashed or dotted, whatever works for you. And now we need to know where to move it. If this is the cubed root of x minus 1 plus 3, where's this graph going? 1 to the right. Where else? Up 3. Let's write that in the little blank down here. So 1 to the right and up 3 with those little points that we have. And that one we make sure we connect up and put our arrows on and everything that we need. So like I said, the one that's not our answer, the parent function is always dashed or dotted because that's just a helper, and then solid when we get to our final answer. What's our domain? You're overthinking. Oh, this one doesn't have a starting point. Not this one. This one does. Square roots do, not cube roots. Do you remember domain and range for cube roots? All real numbers. Goes right and left forever, goes up and down forever. There we go. So, square root, it's a good thing Justin brought that up. Square root always has a starting point. So that's where we have to be picky about our domain and range. But with cube root, all reals. Right and left forever, up and down forever. Now, we did several of these in class too. Rewrite the function to make it easy to graph using the transformations, because this is not right. We want it to look like that. There's a number up there that's messing all that up. What number is it? The 16. Can we factor out a 16 out of both of those terms? Then let's take it out of there. But we're going to take the square root of 16. And I think we know what the square root of 16 is. What is it? It's 4. And this one doesn't even say describe the transformations. It just said rewrite the function to make it easy to graph. We did that. That's what you do. You factor out whatever number's in front of the x. Makes it easy to graph. All right. That's the practice test right there. So the next thing I will do is get you a candy partner so that you can keep working on that review from yesterday.